Every bit of electronics that we use, the roads, the transport system, water, the government decisions that are devised by information that's come from academic research. I don't think there's a single aspect of UK life that isn't affected by research.
We need, for the United Kingdom, to be playing to its strengths, and one of its key strengths is the capacity of its higher education system to deliver top-end research.
If we're going to have a future on this planet, how we're going to solve those problems is going to be something that comes out of university research.
The team at Southampton University's Optoelectronics Research Centre played a pivotal role in the development of optical fibres that underpin the Internet. Professor David Payne's invention of the erbium-doped fibre amplifier greatly extended the distance over which digital signals could be transmitted. At the time, in 1987, this was viewed as blue skies research.
It changed the world when it came to telecommunications, and here it is changing the world again in industrial processing, manufacturing, cutting, welding, making holes in jet engines. An amazing variety of different manufacturing techniques. The role of university research groups such as this is to explore. It's risky, and you can't expect industry to be looking 20 years ahead. There is currently enough fibre to circle the world 26,000 times, and we're installing it at about 1 million kilometres per year.
By 2010, this invention has resulted in the creation of 10 local companies using technologies derived from the centre, generating annual revenues of over £100 million, employing over 500 people, and establishing the Southampton area as a centre of excellence in photonics.
The oasis is the place where the ideas are generated. There is a very dynamic place, so that connection is always important.
School children, we need the next generation of scientists and engineers. The way they get hooked on a lot of these subjects is through being inspired by some of the research that's coming out of universities. It's not by the research that's coming out of industry. It's some of this blue sky, exciting, sexy areas of science that inspire the next generation.
Earlier this year, Surrey Satellite Technology Limited won a contract to produce 14 navigation payloads for Europe's Global Navigation Satellite System programme. This achievement topped a list of successes, with 34 satellites already launched in space and 7 currently in production. It has total export orders secured to date of over £490 million. In 2009, SSTL also made history when it became the largest ever university spin-out.
And space is one of the sectors where, despite the recession, we've seen key growth. And in a recent study put forward to the government, it's become clear actually just how important space is to the UK economy.
SSTL, currently employing over 320 staff, have offices less than a mile from Surrey Space Labs, the university's Space Engineering Research Centre.
What is particularly unique about the setup between Space Centre and SSTL is that ideas can come into from the Space Centre, academic research gets fed into the company then essentially builds and launches those. The results of those go back into Space Centre, and that wheel turns and feeds the research exploitation cycle.
There are many, many examples scattered around in science and technology where taking that risk, looking at an area that's new, that's not obvious how it's going to lead to some benefits, suddenly develops into an area that has huge economic, societal benefits, and that then gets picked up by industry. But it started in academia.
The work carried out by Professor Alf Adams and his team at the University of Surrey back in the 1980s led to a breakthrough in laser technology to produce high-efficiency, high-performance lasers. Known as the strained quantum well laser, this technology has found its way into everyday use in systems as diverse as CD and DVD players, metal cutting and welding, as well as enabling light-speed optical communication required by the internet. One of the many new applications is high-efficiency LED lighting.
And if we can actually make lighting much more efficient by using this kind of technology, then it will have a big impact on our impact on the environment and also economic impact as well.
One of the leading companies producing strained quantum well laser devices is Aclaro in Northamptonshire.
Ask someone to count how many lasers they've got in their house. And if it's 2, I'd be surprised. If it's 20, I wouldn't be surprised. They're everywhere. Sometimes we want we work with the universities because we've got specific problems we want them to solve, and often they've got the brains and the bandwidth and the knowledge to get in there and solve detailed problems. But longer term, it's about ideas and getting the free thinking that comes in the universities.
I think it's important to recognise the importance of blue skies research, and whilst I've been talking about research with impact and the exploitation of the knowledge base, curiosity-driven research must not be ignored.
The National Oceanography Centre in Southampton, which is a collaboration between the University of Southampton and the Natural Environment Research Council, is one of the world's leading centres of ocean and earth science. Ocean research is a relatively new science, with advances in technology and techniques allowing a better understanding of this vast and sometimes hostile environment.
At the moment, the oceans are taking up approximately 1/3 of the carbon dioxide that we have been putting in the atmosphere since the beginning of the Industrial Revolution. And one concern is whether the oceans will continue being able to sink to absorb carbon dioxide.
So obviously if we understand the system better, we're making measurements in the oceans, we're checking whether the models are making reasonable predictions. That gives more confidence in the predictions, that gives the government more confidence in making policy decisions.
What we are seeing is now increasingly an interest in the sort of work that we're doing from Environment Agency, UK SIP as well, and now increasingly also the insurers are getting very interested in getting these sort of worst case scenarios quite accurately portrayed.
Continuous monitoring across the Atlantic is also providing an alert system in the event of rapid climate change. Long-term research such as this can point to issues that may not affect the man in the street now, but they will be important to his grandchildren.
The ambitions of our research are not confined to these islands. And in many instances, the take-up of the new ideas, the new technologies, the new ways of working will be outside the United Kingdom.
As people in the developing world are drawn to cities for employment, unplanned housing often takes place on marginal or unstable ground. High rainfall can then trigger landslides, causing devastation to these communities and requiring humanitarian relief. Professor Malcolm Anderson and Dr. Liz Holcomb self-funded a trip to St Lucia to test the theory that strategic use of drainage channels could avert these disasters.
We thought really we could come up with a methodology which we call Mosaic, that we could promote to governments. We could try to persuade people in the communities to help us with, which is a very important component of what we do, and that would provide major funders, major policymakers like the World Bank, USAID, UNDP and those partners who we've had the privilege of working with latterly, to change their view as to how we should manage landslide risk in communities.
What we've done is we've compared the cost of the projects that we've been doing and found that it's about 2% of the relocation costs. By building drainage and reducing the landslide risk, you're hopefully avoiding this massive cost of relocation.
The results were completely successful, and the Mosaic system is now being rolled out in other parts of the developing world.